Hello and welcome everyone for the next algebra session. So we have had two algebra sessions till now.
Now we are ready to start with linear equations. So in linear equations, uh, there are two types of questions. One are those in which the questions are linked or related to the theory of algebra behind the equations, which is uh, a pair of equations can have infinite unique solution, no solution, or infinite solutions. So algebraic problems are asked around that, and then there are word problems, you can say, uh, in which you have different style of problems in different context, and we have to create the equations with regards to the given situation and solve for the given problem. Like questions can be about some kind of age problem, marks obtained by some students, and etc. So as always, I have designed the session keeping in mind the relevant recent year problems. So you'll be exposed to some new style of problems, right, which will help you to get, you can say, familiar with the kind of questions that can be expected in algebra. So beginning with the first problem, here we go. So let's start. Okay, now here's the first problem. Okay, so let's see. We have been given that for positive integers a and b, consider the system of equations in x and y. So we have two equations, x and y. 4x plus ay equals 12, bx plus 3y equals c. If the system has infinite solutions, which of the following values can c never take? Perfect. So this is the kind of style of the problem we have seen many times, where the questions are mostly put in the negation style, right? So system has infinite solutions, but which of the following values can c never take? So you have to find all the possible values of c over here, and then uh, out of the four options, three would be possible values of c, and you have to mark that option which c can never take. So what's the condition for infinite solutions? uh, so the ratio of the coefficients are the same and also equal to the ratio of the constant terms. So we get the relation that 4 by b should equal a by 3 should also equal 12 by c. Now since we are focusing right now on, let's say, a and b, from this equation, let's say, we are getting that a into b equals 12, because the primary constraint is first on a and b, which are positive integers, right? So given that we have now this result to be satisfied, 12 is the product of two positive integers, so it has quite limited possibilities. So we are looking for those possibilities. So 12 can be thought of as 1 into 12, 2 into 6, 3 into 4, and the other way around also, because it's ordered values which are important to us. So 4 into 3 is also is a different combination of values, and then 3 and 4, and 6 and 2, and then 12 and 1. So these are the six possible combinations we have. Now coming to C. So let's say we equate this ratio of coefficients of x with the constant terms. So we should have, obviously, that 4 by b should also equal 12 by c, right? It was already equal to a by 3, it should also equal 12 by c. So from here, 4 cancels, this is 3, so c is thrice of b. So already we have written all the combinations of b over here, 1, 2, 3, 4, 6, 12. So c will take those values which are thrice of this. So therefore, correspondingly to these, c can take the values which is 1 into 3, 2 into 3, 3 into 3, 4 into 3, 6 into 3, 12 into 3. 18 is possible? Yes. So that's not my answer. 18 is possible. 36 is also possible. Yes. That is also not my answer. Therefore, 9 is also possible. So that is also not my answer. So 27 is the answer. 27 is not a possible value of c. So integer constraint on parameters and then asking something. This is a common style of questions we have seen many times. So working on all the possibilities and then getting to a mark which is not possible. All right, let's look at the next one. Again, this is something based on the algebra of um, yes, Prince. Good evening. Let's solve the problems together. Okay, now, so let's try this one. Let me give you a minute to think on this and then we'll discuss. All right, let's see now. Now, again, let P and Q be two numbers, not necessarily distinct, selected from the set of first 10 natural numbers. So basically, P and Q can take the values from 1 to 10. They are natural numbers by default, right? Because they are selected from 1 to 10. And they are not necessarily distinct, so they can also be equal to each other. Consider the following equations. We are given two equations. How many pairs P and Q are possible of values such that both x and y are integers? X plus y equals P, first equation. 2x minus v equals 2x minus y equals q, second equation. All right. Now, uh, it's very easy to eliminate the variables over here and find x and y in terms of P and Q. The constraint is P and Q are integers. We already know x and y should also be integers. How many values of P and Q satisfy this constraint that x and y also take integer values? So we must solve for x and y in terms of P and Q and then think about what combinations of P and Q can help us reach to such combinations. So let's add the two equations because you can see y will get eliminated. So 3x y cancels equals P plus Q. So x equals P plus Q over 3, right? All right. Now look at the equation. X plus y is P. P is a natural number. If we can make x to be also an integer, y would automatically be an integer. So we only need to work on x, can I say, right? Which is P plus Q by 3. So it is our motive to make this an integer and then our condition is satisfied. So P plus Q by 3 is an integer, means P plus Q should be a multiple of 3. It's 3 into an integer, it's a multiple of 3. And then we have on top of that P and Q falling in a certain range, right? So now this becomes a counting problem, right? We have to count, and I don't think so we have any I mean we cannot count this just directly. We have to actually manually figure it out, right? So let's start. Let's put values of start putting values of P, and let's correlate what combination of values Q can take. Let's see what happens. So starting from P equal to 1, what values can Q take? 1 plus something should be a multiple of 3. So obviously 1 plus 2, 3, or then you can keep on adding another more 3. So 2 plus 3, 5, 5 plus 3, 8, and that's it. We cannot go to 8 plus 3, 11. So we have 3, can I say, combinations here. Now, let's keep on writing because we don't know what happens, what pattern will emerge. So this is now counting question. Let's see what pattern we get in terms of this counting. If P is 2, then Q is 1, 2 plus 1, 3, or 1 plus 3, 4, or 4 plus 3, 7, or 7 plus 3, 10 also. So now there is a deviation. Here we had 3 combinations, but here we have 10 combinations. What if P is 3? Q can be 3 itself. Remember, they can be the same. right? Or 6 or 9, again 3 combinations. What if P is 4? Q can be again what? 4 plus 2, 6, or 2 plus 3, 5, 5 plus 3, 8. Now, for the first time, you see there's a pattern emerging. This 258 appeared here. Again, it has appeared here. So, you can you understand that these three combinations will now keep on repeating as the values of P will take three subsequent values. So, when I'll put P equal to 5, again, Q will take these values which we had written earlier, which were 1, 4, 7, 10. So, what I'm saying, 3 plus 4 plus 3, 10 solutions were there for three values of P, 1, 2, 3. Again, the same 10 solutions will come for 4, 5, 6. Another 10 solutions for 4, 5, 6. P equal to 1, 2, 3, 3, 10 solutions. P equal to 4, 5, 6. Again, we'll have 10 solutions. 7, 8, 9. Again, 10 solutions. 30 solutions. And when P will be 10, it will be the same as P being 1. It will again give us 3 more solutions. So 10, 10, 10, and 3, total 33 combinations of P and Q are possible. So through this question, we are understanding that quant questions are not very, they don't work in silos. Okay, I'll just, work on algebra. So simultaneously, it's a question of counting, you can say. Means, in a way, uh, kind of the way we do counting problems in PNC, right? But more of manual counting. But still, in manual counting, we found a systematic way of counting. So now, third one. Okay, so let's see how can we do this problem. This is something to do with buying fruits. Let's see. Kajal goes to a fruit market with a certain amount of money. With her money, she can buy either 40 apples or 70 mangoes. She needs to keep aside 15% of her money for the auto fare to go back home. With the remaining amount, she bought 42 mangoes and some apples. How many apples did Kajal buy? So the only thing to understand is that what is this statement? She can buy either 40 apples or 70 mangoes. It means the cost of 40 apples is the same as the cost of 70 mangoes and equals the total amount she has with her to spend. Right now, so let's work in percentages because here we can see a percentage. So 15% is reserved for her fare out of the total money available. Now, it would be therefore suitable that we convert this amount of mangoes, 42 mangoes, in terms of the percentage, right? Because we know she has her money is equal to 70 mangoes, right? So how much percentage of her amount did she spend on mangoes? 42 is 60% of 70, right? 60% of 70 is 42. So this is gone. Mangoes 60%. So therefore, fair and mangoes add up to a total of 75%. So therefore, the remaining 25% she can spend on apples. And now we can turn back to the statement that she has enough money to buy 40 apples. So 40 apples is her total amount. So 25% of her amount she can buy, obviously one fourth of 40, which is 10 apples, right? So the thing in this problem was that although we did not have any monetary amount in with us, but we were just working in terms of the proportion or the percentages we had, right? So you should not expect questions to give you numbers and create equations, right? So algebra is not always about creating equations and solving them. It's also about just working with the given data, and you might only need to be, just working with ratio and proportion and percentages, and you can get the answers. So you see how less I wrote over here, right? Whatever I wrote, I could have done in my mind also, right? So that is what we are learning, how to do mental maths, right? All right. So this was this one. Next one. Something to do with now marks, uh, percentage. Anita failed after scoring 30% in an exam. Her friend Sujata scored 20 more marks but still falls short of the pass percentage by 7.5%. If Anita had scored 75% more, she would have got 4 marks more than the passing score. What percentage did Geeta, Anita's friend, get with a score of 100? So the problem involves three people. One is Anita, then there is Sujata. So their marks are basically given in terms of percentage of the total marks and something like that. And some then if then condition about Anita's marks further is given. And then we have to find the percentage of marks scored by Geeta, who got a score of 100. So obviously, we need to find the total marks of the exam in order to then answer this question, because the answer to the question will be 100 is what percentage of the total marks. All right, so let's take the total marks as some variable, because uh, now because everything is percentage of marks. So let me take the total marks as not x but 100k x, or let's say 100k, right? Always what I do is take the total to be a multiple of 100, so that I'm I mean there is less chance that I will get into some decimals. Fine. So Anita gets 30k marks, that is her original marks which she had got, right? 30k, 30%. Now Sujata scored 20 more marks. Sujata scored therefore 30k plus 20, but she still fails. See, she falls short of the pass percentage by 7.5%. So can I say that if let's say x is the percentage at which passing percentage, x is the pass percentage, then her score, Sujata's score, is x minus 7.5% of the total score, which is 100k. That is what this means, right? She falls short of the pass percentage by 7.5%. All right. So let's work on this now. 30k plus 20 is x percent of 100k. Let's call that as the passing score p minus 7.5% of 100k, which is 7.5k. X percent is the passing percentage, and I'm calling p as the passing score, which is x percent of 100k, right? Okay, now this is one equation. We have something in k and p. We have some further more information to analyze. Perhaps we should get one more equation in terms of these parameters, right? So this is turning out to be a typical creating the equations and solving them. So this simplifies further as this equation, because this goes over there. So p equals 37.5k plus 20 is my first equation. Now second equation, if Anita had scored 75% marks more. So Anita's score was 30k. If she scores 1.75 times of the score, so if Anita's score had been 7 by 4, which is 1.75 times of 30k, which is 2 cancels, this is 105 by 2k, right? I never like to write decimals. I always convert decimal to fraction. 105 by 2k, which is 52.5k. Fine. She would have got 4 marks more than the passing score. So this 105 by 2k is 4 more than the passing score, and passing score I have taken as p. So equation becomes, this is p plus 4. All brilliant. We now have our second equation in terms of p and k. All right. So I think we just need to solve now. 105k equals 2p plus 8. Let's substitute p as this expression from the first equation over here. So this becomes twice of this, 37.5 into 2, 75k plus 40 plus 8, so 48. 105k is 75k plus 48. 30k is 48. K is turning out to be 48 by 30 or 1.6. So therefore, we I think have our answer that our total marks are 100K, which is 160. Brilliant. And therefore, Geeta's percentage is 100 on 160. She has got 100 out of 160, which is 5/8 fraction, which is 62.5% marks. All of us, I hope, are completely aware and familiar with fraction to percentage. Standard percentage is 1 by 8, 12.5%, 5 times of that, 62.5%. Right. So all your fraction to percentage numbers you should be completely thorough with. Right. So pretty routine algebraic problem where you carefully had to create the variables, the equations, and solve for them. All right. So now turning to some of the recent year problems. Okay, so this came in CAT 23, and something similar to what we discussed earlier. For some real numbers a and b, the system of equations x plus y equals 4 and a plus 5 times of x plus b squared minus 15 times of y equals 8b. So complex equations, lots of variables, coefficients are in terms of squares, but don't worry, just follow the things. Has infinitely many solutions. So we know infinitely solutions means ratio of coefficients is the same and also equals the ratio of the constant terms. Then the maximum possible value of a into b is. So the question suggests that there should be multiple possibilities for the values of a and b from this condition. Find all those combinations from that, search for the maximum for that combination where a into b that is maximum. All right, so let's just write what we have. This equation, second equation, and first equation, I'm writing the ratio of coefficients. So a plus 5 coefficient of x, over there it is 1, so a plus 5 over 1 equals b square minus 15 again over 1 and equals 8b over 4. I'm writing directly 2b. Now therefore, since this is 1 and 1, practically it is just simply b square minus 15 equals 2b. We have a quadratic equation in b. So we should be able to solve for the two possible combinations of b, I guess, from here, right? And then we can do the maximization of a into b. So our quadratic is b square minus 2b. This comes over here, minus 15 equals 0. So this is an easy factorization, minus 2. So minus 5 plus 3, 5 minus 5 into 3, minus 15. So this becomes b minus 5b plus 3 equals 0, right? B is either therefore 5 or minus 3. Brilliant. Okay, so from the equation, a plus 5 is 2b, or you can say a is 2b minus 5. So when b is 5, then a is 2 into 5, 10 minus 5, which is 5. And when b is minus 3, then a is 2 into minus 3, minus 6, minus 5, which is minus 11. In this case, a into b is 5 into 5, 25. And in this case, it is minus 3 into minus 11, minus minus cancels. It's 33. This is the higher value. So that's the answer. You can also see the trap option of 25 was kept over there, right? But it's 33. All right. So this was this one. Pretty routine, I would say, if all of us are familiar with all the conditions of infinite solutions, no solution, unique solution. All right, next problem is on a similar lines. This is a ZAD problem, recent problem. ZAD is known to give quite logical problems. Now, let's see here. You can see there is, the options are quite illustrative, right? They are about, question is asking, consider the system of two linear equations as follows and PQR, and which of the following statement definitely contradicts the fact, that the lines represented by the two equations are coinciding. So coinciding lines is basically nothing but that infinite solutions, right? Coinciding lines on the graph, if the lines are coinciding means they are identical lines. That is what it means to have infinite solutions. So that should definitely not happen. Which option does that, right? Okay, so let's write the condition and then start thinking about it. Options are like, P and Q have opposite signs. Smallest among this is this. So either options are about the plus or minus sign of the variables, or about which is the smallest, which is the largest. Kind of options are there. Let's see. Now, so our condition will become that 3 over Q. I'm writing correspondingly ratio of coefficients 3 over Q should equal 21 over R should equal P over minus 7. So let's just simplify or express this three-way equality by expressing two variables in terms of the third. All right. So let's say we can say over here R, between R and Q, 3 cancels. So this is 7. R equals 7Q. R is 7 times of Q. And let's say again we write P in terms of Q. So this minus 7 goes over here. P is minus 21 over Q. P is minus 21 over Q. All right. Now with this that we have, let's turn to the options. P and Q must have opposite signs. P into Q is minus 21. This supports the fact that the equations are coinciding. This does not contradict that. So this is not my option. Since P into Q is minus 21, so definitely P and Q have opposite signs. So this is not my correct choice. Right? P and Q, if they must have opposite signs in order to support the fact that the equations are coinciding. Right? So you have to think through carefully, right? The smallest among P, Q, and R is R. Smallest. Okay. P, Q, and R is R. R is 7 times of Q. R is 7 times of Q. Now, P, Q, and R are real numbers. Okay. P, Q, and R are real numbers. Let's say if R is 7Q, so if Q is 1, then R is 7. Right? In this case, R is not the smallest. If I take Q as minus 1, then R is minus 7. And correspondingly, P is also right. P is minus 21 over Q is 21. In this case, R is the smallest. So this is a statement which is not necessarily true, right? So opposing this statement would also not definitely contradict the given statement. For if this statement is true, then it does not definitely support the fact. So if this is not true, then this is not then again we can say that it is not definitely contradicting, right? Or in simple terms, if this statement is true, then it is not definitely contradicting the given fact, right? So this is a kind of dicey statement, right? This is therefore not definitely contradicting the given fact, right? So this is also not my option. Come to the third option. Largest among P, Q, and R is Q. Largest among P, Q, and R is Q. R is 7 times Q. P is minus 21 by Q. Largest is Q. Okay. Now, again, consider the possibilities of the variables. Let's assign Q as 1 again. Then R is 7. If Q is 2, R is 14. If Q is anything, if Q is anything positive, R being 7 times of it is definitely larger than Q. So in general, if Q is positive, then it is definitely not the largest because R is greater than Q. If Q is positive, then definitely R is more than Q. So this cannot be true. Now consider if Q is minus 1. If q is minus 1, then what is p? P is minus 21 by minus 1, which is 21. And in general, if q is negative, then p is definitely positive. A positive number is always more than a negative number. So here we have, I think, our statement that we are looking for, right? Because now this is definitely contradicting the fact that the lines cannot coincide, right? The largest among P, Q, and R will never be Q if the lines are coinciding. So this contradicts the fact this is the statement we are looking for. So a highly analytical problem, uh, right? And this is the kind of things I guess where uh, you have to think with algebra, I would say. All right, let's see. This is Cat 21 question. Coming back to something to do with fruits, we have apples, oranges, mangoes. Let's see. A basket of 2 apples, 4 oranges, 6 mangoes costs the same as a basket of 1 apples, 4 oranges, 8 mangoes, or a basket of 8 oranges and 7 mangoes. The statement is a three-way equality of a combination of fruits. This is the same as this, is the same as this. Then the number of mangoes in a basket of mangoes that has the same cost as the other baskets is. Now, as soon as you see this, you understand there are three variables involved, three parameters: apples, oranges, mangoes. But one thing is that amongst these three combinations, there is one combination, which is oranges and mangoes. You can see which is only having two things. So can I say if I can find the equivalence between oranges and mangoes, that how many oranges are equal to the cost of how many mangoes, then we have our answer directly, right? So we are searching for that. Let's designate the cost of one apple as x, that of one orange as y, and that of one mango as z. Then we have our equation. First, write between the two variables. We have 2x plus 4y plus 6z is the same as 1x, 4y, 8z, which is also the same as 8y because orange is y plus 7z. This is our equality, 7z. Now, you one wonderful thing, one helpful thing for us is that between the first two equations, the y parameter cancels off. It's the same number of oranges in both the sides. So we directly can write from here that 2x plus 6z equals x plus 8z, which means that we have that x is twice of z. So this is helpful. It gives us a start. Although our objective, you can understand, is to find the equivalence between y and z. So we can further use this. Now let's equate, let's say the second and third equations. We here equated the first and second. Now let's equate these two. So x being twice of z. So let's substitute for that. X equals twice of z. 2z plus, so okay, I'm directly subtracting 8z minus z over here equals 8y minus 4y, 4y, right? So therefore, I guess we have the equivalence we were searching for. 3z equals 4y. We want to substitute for 8y because we have to find this equivalence in terms of the number of mangoes, right? So therefore, can I say 8y therefore equals 6z? So substitute for 8y as 6z. This equals 6 plus 7, 13z. So therefore, 13 mangoes is the equivalent cost of the given baskets. So always keep the objective in your mind, right? And we only had to find the equivalence between the parameters, right? We don't have any monetary number over here. This question was not about solving for three equations with three variables. It was just about finding the ratio of the costs, right? So don't be worried, or don't think that as soon as you see three quantities, there are you have to solve for the equations in three variables, right? That obviously is a time consuming process. Just finding the ratios was required. All right, let's see next one what we have. Okay, an age problem, right? Last year's only. Now, in any age problem, we always have something. We typically mostly we have uh, to do past with present, past with future, present with future, present with past, or all three of them, right? Means obviously questions are about giving the age in different time uh, situations, right? So this question is about uh, past, present as well as future, because when Rajesh's age was this, the ratio was this, when Garima's age becomes the same as the present, so now we are going in the future, right? So what is typically uh, helpful is to kind of just make a kind of a small structured tabulation of the ages of the persons, keeping in mind the past, present, future, right? It means something like this. So there is Rajesh and there is Garima. There is past, present, and future, right? So we are trying to write the expression for their ages in terms of some variable, let's say. If because you don't see again, you don't see any number over here, you only see a ratio, and the answer is only also expected in terms of a ratio. So since numbers, actual value of age is not there in terms of years, we are typically expecting to write the ages in terms of a single variable using ratio, right? So when Rajesh's age was the same as the present age of Garima, means this number over here, when Rajesh's age was the same as the present age of Garima, so these two are equal. The ratio of their ages was 3 to 2. So this ratio of 3 to 2 has to be understood whether is it is mentioned for the past or the present. The ratio of their ages was past. So in the past, their ages was 3 to 2, and at that point of time, Rajesh was as much old as Garima is now. So clearly, Rajesh is older than Garima, because Garima becomes older as as old as Rajesh in the future, right? Okay, so 3 to 2, I will define the ages as some 3K and 2K in the past, and Garima is now 3K as well, as old as Rajesh was. Now, what becomes the present age of Rajesh? The only logic in any age problem, good Prashant, Prashant, very good. In any age problem, the only logic is that age difference remains constant. Age gap of two people remains the same. So we are not traveling in some time machine, right? So I age as much as you age, right? So our age difference remains constant. That's the only logic in any age problem. So this difference in ages is k over here. So here also it should be k. So 3k plus k, Rajesh should have become 4k. Now the question goes to the future. When Garima's age becomes the same as the present age of Rajesh, which means now this 3k will become 4k, Garima will become as old as Rajesh is now. The ratio of the ages will become how much? So again, the difference is k. So this is 4k. So this is plus k, 5k. Hence, the ratio is 5 is to 4. Right? Brilliant, brilliant, and good response. So this is what is required, right? Writing less, getting to the answers quickly, and working on ratios. All right, I'll take the last problem now for today's session. Again, something on ages. This is another CAT problem, a bit of a lengthier one, but still, if you follow the same technique, it can be done. So what I'll do, I'll give you 2 minutes to do this, and we'll discuss this. If you get this, let me know. All right, let me start discussing. I'll still see if somebody gets this. Uh, Let me know if you get this. Now, so the problem talks about a couple. Then first child is born, then second child is born, then they get a twins, three and four all together. So it becomes a six-member family, right? I don't know how much that is feasible in today's day and age. Okay, Prashant, good, good, good. Prashant, good. That is the correct answer. Brilliant. Now, let me discuss this. So you can see that average age is given for 20 for the couple. So since the question asks for the age of the eldest child, so I don't think so. We are bothered about the individual ages of the husband and the wife, right? So since the average age is 25 to start with, so let's take their age as 25 itself. It does not make any difference, right? Uh, okay, so therefore, let's say the husband is also 25 years of age initially, and the wife is also the same, right? And right now, that is the situation. Then the next stage comes. The average age of the family just after the birth of the first child was 18 years. Okay, so when the child one comes, the sum of the ages of three persons will become 18 into 354, and the child would be 0 years of age. When you're born, you're a zero, right? That's your start of the innings. Okay, so since now 54 is the sum of the ages and child is zero, so it means 54 is husband plus wife, 27, 27, because we started with them equal in age. So means the first child was born 2 years down the line, right? They are now 27, 27, right? Child 2. Now, the average of the family just after the second child was born was 15. Again, when the second child is born, he'll again be 0. And 15 is the average age of four people. 15 into 4, 60 should be the total age. Now, I'm writing just a column over here for the total age also, just so that it's in your mind. Here it was 50. Here it was 18 into 354, sum of the ages. It was 25 into 250 here, 18 into 3, 15 into 4, 60 should be the sum of the ages for all the four members now. And everybody should age by the same number of years. These three people right now they're 54. The sum of the ages, they should become 60. So this plus 6 which is happening should happen equally for each of the three people. So each of the three people age by 6 by 3 2 years each. So therefore 29, 29, and 2, that adds up to 60, right? That uh, that justifies the given average. Now child 3 and child 4, they drop off altogether in a bundle, twins, right? So now we have six people, right? So 12 is the average now. So 12 into 6, which is 72, should be the sum of the ages. Each of them are now 0 0, and these four people should age by the same number of years. 60 to 72 is plus 12. So 12 by 4, 3 years. Everybody should age by 3 more years. So this happened 3 years further. So 29 plus 3, 32, 32, 2 plus 3, 5. And this child is now 3 years of age, right? And this is what happened. And then finally, if the present average age of family of six persons is 16 years, how is the eldest child? So obviously, if average age has increased by, so from 12 to 16 it has increased by 4 years. So obviously we are talking of a timeline 4 years further down the line. So how old is the eldest child? So we are talking of 4 years further, which is 5 plus 4, 9 years, right? That is the answer. So this kind of tabulation kind of approach in age-based problem is what I would suggest always helps us. It makes things neat. We write things efficiently, right? So with both these two questions, I hope you will be very comfortable with age problems. So this was our first session on linear equations. We'll meet again in this week, and I hope this was, I mean, um, you know, I have kept the session very relevant to the current pattern, designed some new questions for you, and we'll continue the same in the subsequent sessions. So therefore, uh, let me know how you felt about the session, what more you would like me to do, anything uh, from your side would help me to design the future sessions as per uh, your suggestions. Today, tomorrow, you'll have GP Ka Jugaad. As always, very informative session by Sir. So, uh, come for that session, right? Our test series is live, and our Blackie batch is also there, and I hope you will make full utilization of that. So, thank you so much, and see you again next time.